Okay, those graphs make me so mad because just when I think I'm doing them right, there's one thing
I
wrong.
have a question on that one. I have a question on 10 and I have a question on 16 because I'm stupid and I'm
Oh, no.
answering questions.
251?
Do it really quick.
I haven't really done
I
Saturday,
think
but
it's important enough.
oh well, so do I.
Me too.
That's what I was explaining this to you. I don't think that's what it's asking.
Alright.
I was like,
Lauren!
Loser.
Heck.
oh, no problem.
What?
What? I hope you heard that Olivia and I just gave your defense at the same time. That is friendship, my darling.
She's probably just gonna skip all this until like. I know.
No,
There's
she's
not
actually
actually.
gonna-
That's embarrassing. So she's just be like, oh, they're really like.
Ah, stupid itchy.
Do you want more lotion?
No, that's not gonna help my stupid eczema disease.
Oh, you're diseased.
Lotion doesn't have
I itch a lot too.
So I bought eczema lotion today, so I'm excited to try it.
Yeah, there you go.
If it doesn't work, I'll
You need some like deep moisture lotion, you know.
Yeah, I'm a little crazy.
Yes.
I like itching myself like I bleed.
You gotta tell yourself you're not itchy too.
Yeah, I tried.
You have to. I mean, you don't have a choice. You either tell yourself you're not itchy or the itch will take over you.
Got this.
Because, like, imagine like Navy SEAL or something,
I know.
right? Like if the Navy SEAL is in, you know, life or death circumstance, I imagine he could stop the itch.
Yeah, he did it.
Right? What? Oh, your eyebrow keeps twitching?
It's like really wild. It's not regular twitching. Like I looked at it earlier and I was like,
No, that's normally from a,
My eye was twitching like right here and it would not stop and I was like, oh my god. It was so annoying all day, it's so
a mineral imbalance, that's normally from a mineral imbalance.
I'm in bed.
Your sodium potassium pump that works at your
Imbalance.
at your nerve like synapses between the axons and the dendrites, right? Does this sound familiar? Remember the diagram with like the two things communicating back and forth with sodium ions? If your sodium ion concentration gets off, it can cause muscles to contract that you're not actually telling to contract, yet normally you do have to tell to contract. So
this must be really awful because those are violent twitches.
no, that's not violent. I mean, she's not like punching people.
Her eyebrows
It's
like,
not-
Sorry.
It doesn't got violent. You're okay. It also can happen from your body becoming too basic. So maybe you need like an extreme
We
amount
tried
of
that.
vegetables.
That actually, okay, when you said that, I actually kind of didn't believe it, but then like, they my friend like tested out.
Yeah.
Like a whole week he'd eat anything, had like, him and like basic.
Mhm.
That dude's arms were literally like flying everywhere, like he'd just sit here and just fly.
Yep.
Like, oh my god.
Metabolic alkalosis is what they call that. You can do the same thing in reverse. You become acidic. If you become too acidic, your nervous system slows down, and you have like slow thinking, and like it's harder to get moving, and all of those things. So
It's like,
that
I've
can
never
hurt.
seen a man twitch so hard, so like that one week when he told me he can't eat any like vegetables or anything like that, he
Yeah.
literally was sitting there and his arm would just go like this.
I wish I had that.
I
I'd love to smack
I
people.
like that story. That's a good one.
I'm sorry.
Yeah.
That's a good example for
I love it.
for alkalosis.
And then me and my friend, he was talking about like, he's like, I don't feel like, he was like trying to like power his car the other day, because he
Okay.
couldn't get batteries, he's like, oh like, what we should do, we should hook up, because you said about like how your lawnmower can like power your car.
Yeah.
We tried that, it works.
You hooked up
Into like his engine part of his front car, yeah, it
Really?
works, yeah.
that's awesome. I've only seen it done on YouTube. I've never actually done it myself. Although the idea makes sense.
It
So
took a while, but he
Yeah,
did it,
just-
he's now driving he was driving, I think his, what's it called? Oh, it was, no, his BMW wasn't like, it was like dead, and I was like, what? Why is your BMW dead?
okay, so let's see. We are. Did I give you homework? And it's from section 61, maybe? Maybe. Okay. So let's. Any questions from section 61? Yes.
Number 10.
Number 10.
Me too. I think I'm really confused with whatever we learned last time.
Okay. It says the mean of a distribution that's approximately normal is 65. And it says the standard deviation is 3. Now it says use the standard deviation to tell how the data are distributed with respect to the mean. This is, what I would do when I would see this problem is start out by drawing a normal curve centered about the mean. The mean is 65. That's the average, and since we have a symmetric graph, the average is going to be the middle. Go 3 to the right. 68. Go 3 to the left. 62. That's one standard deviation. How much data is within one standard deviation? 68%, 34% on each side. Go 2 standard deviations, that's 3 again in each direction. That'll take you up to 71 and down to 59. How much data is within 2 standard deviations? 95. Good. That's really all you need to say. So, they ask you to describe the data to tell how the data are distributed. From 62 to 68, there is 68% of the data. And from 59 to 71, there is 95% of the data. I think that would do it. Because what you're saying is, what you're doing is describing the distribution of the data. That's what they wanted you to know. So taking advantage of the normal curve, those would be the 2 pieces of information that they're looking for, really. Within 1 standard deviation, there's this much data. Within 2 standard deviations, there's that much data. And you can find the ranges by just taking the mean plus 1 standard deviation and the mean plus 2 standard deviations, and then going in the opposite direction, the mean minus 1 standard deviation and minus 2 standard deviations. Soon someone took the time to figure out the table for not just 1 standard deviation, not just 2, but like 1.1 and 1.2 and 1.3. So we'll start breaking this down further into like smaller and smaller sections. So what if you were 1.5 standard deviations away? How much data would be to the right or to the left of that? We can figure that out, and somebody took the time to put it in the table. We'll get there eventually. But for now, this is good. Anything relating to randomness can go on a normal curve. So this is really common in any sort of study involving people. Because people tend to have traits that are randomly distributed among the population. You probably encounter this on a daily basis, like the wide spectrum of personalities, right? So when it comes to a study of behavior, when it comes to a study of personality, when it comes to a study of anything involving people, even with strict genetics, height, normally, it's on a normal curve. So I bring that up as, depending on what you get into, this may be something that you see a lot of and get really comfortable with. The normal. Any other questions? Yes, Olivia? 21. Okay, we go up to 4 and down to -8. Here's the center line. It looks like there's a bottom out point here, and there's a top out point there. Just trying to recreate here. And we'll follow that one all the way over here. The top out point is at 3 pi over 4. This intersection point is at pi over 4. And this other top out point is at -5 pi over 4. And this says, write in terms of the sine function. Now, where does the sine function normally start? At the y-axis or where the y and x-axis meet, and then it goes up. So normally we would expect to start here. So what does that mean for our sine function? This guy's been shifted, right? Right pi over 4. Or 45 degrees, is that what we said? Exactly. Okay, what else do we know about this graph? We know it's peak and valley measure, how tall the peaks are. If the whole graph is 12 tall, each peak is 6 tall. And if each peak is 6 tall, then up from -8 would be at -2, and down from 4 would be at -2. Our center line at -2. You can always average the numbers. If you're not sure what's in the middle, you can always do what in geometry finds the middle between A and B, finds that balance point. It's the average, A plus B divided by 2. So take 4 plus -8 divided by 2. That'll do it every time to find that middle number, or you can kind of try to visualize it as well. The way I like to think of it is find the whole gap, cut it in half, and that's the top and bottom, and then work from there, but either way is fine. Yeah, and then what else do we need to know? Because we know the amplitude, we know the shift, we know the center line, period. Here it goes, right there. From top of peak to top of peak. -5 pi over 4 to 3 pi over 4. How do you find the distance there? Well, the negative distance is 5 pi over 4, the positive distance is 3 pi over 4. Add those together. You get 8 pi over 4, which is 2 pi. That's the expected period. That's the period that you would hope for. The multiplier is 1. And I think I mentioned this before, but normally when there's a horizontal shift, there's not a period shift. And when there's a period shift, there's not a horizontal shift, which was the case in 22. 22 had a period shift. The period was 90, whereas the horizontal shift was 9. So let's put this all together, okay? Question?
The period shift,
Mm-hmm.
I got confused because I took it to like the 7 pi over 4.
Mm-hmm. Mm-hmm. So in that case, if you did, from the bottom, you'd go to the next bottom, which would be here.
Oh.
And that bottom appears to be, if 2 pi over 4 is the length from here to here, then 2 pi over 4 would get you here. That'd be -pi over 4.
Oh.
So there's 1 pi over 4 plus 7 pi over 4, so that's 8 pi over 4.
So just looking at the pi over 4 to the 7 pi over 4, that's not right.
Yes, that's not right,
Okay,
because
that's
that would
right.
be from here to down there. That's not gonna be a full period. Full periods would be, if you wanted to take the full period from the bottom, you'd have to find an exponent at the bottom. If you wanted to take the full period from the middle, where the graph was going up, you'd have to go back to where the graph was at the middle and going up, which would, in that case, be -7 pi over 4. One way that period is described sometimes with a wave is the distance from peak to peak, or the distance from valley to valley. So sometimes that's a description, because that's an easy one to describe. I prefer length of one cycle, but that's it's up to you. So we're off of y equals sine x. We're not just y equals sine x. First off, we're a positive sine graph because we're going up. And our amplitude is 6, so we're times 6. We're not sine of x, we're sine of x minus pi over 4. Because we're shifted to the right. And we don't have to put a multiplier here because our period has a multiplier of 1. So if we did put a multiplier, we just put 1 times the parenthesis, which just means the parenthesis. And what else do we need to show? We need to show this -2. If I'm circling the relevant information, there it is. The period is 2 pi, so 1 multiplier. Emptied 6, so where are we at? 7 minus 2. So there's always a plus or minus, there's always an amplitude, there could be a multiplier, there could be a horizontal shift, and there could be a center line. Those are your things to look for. Amplitude, period multiplier, horizontal shift, center line. almost, you have to be like an investigator, because you gotta like find the information from the picture, and the information may not be clearly articulate, you might have to read between some lines to figure out what the period is, for example. I agree, these are tricky problems. Any other questions from the homework? Any other questions?
Did you try to?
I don't believe so. That would be good practice. So this guy goes up to 7 and down to -3. That's a gap of 10. He starts right at the origin as you'd hope him to. Goes like this. So he starts just right for a sine graph. He starts right where we want him, no horizontal shift. But when you look at the period, here, the next time we're at the origin going up, there's only 90 degrees away. So that means the period is 90 degrees, which is
Oh,
Nice.
sweet.
so the period multiplier is 4. Let's work with this 10 figure. That means the height of each peak is 5, yeah? And if you go down 5, you're at -2. And we have no horizontal shift, so we just need to take these 3 pieces of information and get them to our equation. So we're multiplied, we're amplified by 5. There's no horizontal shift, but there is a multiplier,
Yay.
so it's sine 4x. And then we're down 2.
What are you up to?
Yes.
Wouldn't it be?
Oh, sweet.
Thank you. Yes, that was an error. 7 minus 5 is 2. Oops. Right? I have the same,
I'm not the only one that makes this.
I have the same sensation you guys do when your test comes back and you get -1 and you feel like a dodo, because you're like, 7 minus 5, -2, really? Yeah, thank you. That's good. Mhm.
When it asks for range,
Mhm.
I know it's like the numbers go from 3 to 8, but does that what they want, or what do they
Range?
want when they ask for range?
Is it, is there,
Number 9, they asked for range.
oh, number 9.
I got the rest of them.
Oh, shoot, yeah, we didn't describe this, because that's an old. The range is the max minus the min. So the range is basically, on a number line, the distance between the highest and the lowest value. I didn't make that clear. I didn't say that at all, actually. Yes. Excuse me for not bringing it up. Range is the span of the data. So if you put, the way that I like to think of this is I put the data on the number line, and I have my smallest value and my largest value, and I wanna find the distance in between. That's the way I see it. That's just the way my mind works though. You may, just like that. That, whatever, that's fine. You get it in your head however it's best to get in your head. You know that because it's your mind, right? Okay. Yeah, no. Nope, not one mind, okay, good. Any other questions from 61?
17.
17?
No, I just like that confused.
Okay, log x plus log x minus 9 equals 1. I assume you started by doing that?
Yep.
And then you only have log on one side? What's our
I
tag?
just log of one. Oh, so it is 10.
10 to the first power equals x squared minus 9x.
So, yeah, equal 10.
Can that be factored? And remember, you may remember this, I
Yep.
got a little little sheepish grin on my face.
I wanna keep positive.
Remember that day last semester? We proved that in our number system, when two numbers multiply to be 0, one of them has to be, but that's not true of any number system. You guys remember that? Vaguely? We had,
Oh, yeah.
that was a mind blow.
Life
Yeah,
doesn't
pleasant.
change mathematics.
So,
It hurts.
we were dealing with the group Z4, which are the remainders of any number when divided by 4. And that was, I point this out because it's interesting stuff. You can create a number system where, the Z stands for Zahlen, that's the Greek word for, or the German word for number. Z is short for the integers. I know you guys know the integers, so I won't belabor that point, but, yeah, right. Zahlen, which is the German word for number. Anyways, yeah, Z4 is that guy, and he is, anyways, for us, this is all we need to know. Now, look at these two solutions, and go back to the original problem. If I plug in x equals 10, I have log of 10, that's fine, and log of 1, that's fine. If I plug in negative 1, I have log of negative 1 and log of negative 10. Not okay. Not okay. Why? Because how could 10 to any power be negative 1? Impossible. Take 10 times itself any number of times, you're guaranteed something positive because 10 itself is positive, and the log is shot down. And you can always remember this if you remember what the picture of a log graph looks like. The graph always lies to the right of the x-axis in this range. And what is true over there? That. So, in this guy here, x has to be greater than 0. And if x is not greater than 0, you gotta reject the answer. So, and that always amazes me because you go through the problem, you make no mistakes, yet it gives you a false answer. Deceptive, right? Cunning. So,
Could you raise, like, how we said, like, you can raise it to the exact log that gets you the answer that you need? Like, we learned a few lessons ago, like, could you raise it to log 1?
no, because this already has a base of 10. So you're forced for the base to be 10, you have no choice there. And you're just forced to plug in for x, that's the only liberty you have. And when you use that liberty, you're nuked. It's over.
How did it come to just like a log base of 10? Like they just hey, it's gonna be 10.
Well, we do this because,
Yeah.
why do we neglect the base 10? Because our number system is based on 10. I sound like a jerk when I say it like that. Excuse me. Our number system is base 10, we have 10 digits. Not all number systems are of base 10. You could have base 2, where you only have 2 digits, 0 and 1. Your computer actually works on that architecture. Your computer is an electrical machine. And electrical machines know 2 things. They know on and they know off, right? So, if you start, if rather than just having one light switch, you have multiple light switches, you could start to characterize things using a base 2 system out to many, many digits. Like, what if we had, think about this, I'm asking you here to step up for a second and focus on something that's not really in the book but is enlightening nonetheless. In our base 10 system, what's the first digit? The first place of the digit is the ones digit, right?
Yep.
And we count up however high we can count, and when we can't count any higher, we move to the next column, right? That's how, I'm getting back to basics, but the idea here is, when do you have to go to the next column? When you get up into the tens, right? Because once you get above 9, you can no longer express in one digit, you need an additional digit, that's what we call the tens digit, the second place over, is then keeping track of how many times you count up the ones and run out of place, right? When you run out of place once, you have a 1, and then you go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I ran out of place twice, so now I'm up to 20. And I'm making it sound really caveman-ish, but that's the idea for this exercise. Now, when you run out of tens, You just counted up tens 9 times, you're up into the hundreds. And as we know here, this is the thousands. But when you start looking at that with base 10, the ones is just 10 to the 0 power. The tens place is just 10 to the first power. The hundreds place is just 10 to the second power. And the thousands place is just 10 to the third power. My opinion, they should never teach place value until you teach exponents. That's my opinion. Because otherwise you just blindly memorize, remember the words, and have no meaning for the actual content. But this is what it means. The ones digit is 10 to the 0, and this is the 10 to the zeros digit, and this is the 10 to the first digit, and 10 to the second digit, and 10 to the third digit. Now, let's think about base 2. You count in the first column until you run out, and then you go to the next column. Well, how high can you count here? You can count to 1, right? Right? And then once you counted to 1, you have to go to the next column. And when you go to the next column, now you're in the second place. Well, that's going to be keeping track of your 2's. This is your 2 to the zeros column, this is your 1's column. Here's your 2 to the first column, which is keeping track of your 2's. Now, how many 2's can you count? 1 before you run out. Then you have to count over here. So, this is the 2 squared column, and this is the 2 to the third column, and this is the 2 to the fourth column, and so on. So 2 to the first, this is the 2's place. 2 to the second, this is the 4's place. 2 to the third, this is the 8's place. This is the 16th's place. 16's place, I should say. This is the 32nd's place, and this is the 64's place. So what if in a computer you wanted to characterize a number like 50? Well, you could break it down into each of these places. How many 64's are in 50? None. How many 32's are in 50? 1. How many, after taking out the 32 that we took out for that one place, how many 16's are there? In 18, 1. Now we took out 16, so we're up to 2. Okay, how many 8's are in 2? 0. How many 4's are in 2? 0. How many 2's are in 2? 1. And how many 1's are left over? 0. Well, if you break the number down like this, 132, 116, 0 8's, 0 4's, 1 2, there we go. A 0 in front we always drop out. That's the number 50. As a computer would remember it. So to a computer, 110010 is 50. And the whole reason is the computer is built on an architecture based on on-off switches. And there's lots of on-off switches. So when you have, actually, the way a computer does it, it actually uses 8 bits. I'm sure you've heard this before. Like when you have a file that you're transferring, maybe it's like 2 gigabytes or something. Have you heard this before? Okay, so GB stands for gigabyte. Now, what is a giga and what is a byte? That's the next question. Now, giga is a metric prefix. You have the base like a meter, and then when you go up to 10 to the third, that's 1,000, you have kilo. When you have 10 to the sixth, that's mega. Yeah, mega, that's right, mega. And when you have 10 to the 9th, that's not a billion, it's giga. If you go beyond giga to 10 to the 12th, that's tera. I don't know if you've heard of a terabyte before, but that's basically a trillion bytes. Excuse me, yeah, trillion. Million, billion, trillion. What's a byte? 8 switches. It's not a byte, it's 8 switches in your computer. So 8 switches, each switch is called a bit in the computer. 8 bits make a byte. That's the conversion. But 8 bits allow you to do 2 to the 8th numbers, which 2 to the 8th is 64, 128, 256. When computers first started, you only were allowed to make 256 individual characters, like 0, 1, 2, A, B, C, and so on. There were only spaces for 256 characters because that's all that the computer could hold. Because back in the day, this was considered the standard. 128 was too few characters, 256 was just the right amount. And we still base ourselves on that architecture today. So giga just means billion. So if your computer has 2 gigabytes of storage, it can hold 2 billion bits. when you transfer a picture file from somebody else, from one person to another, and it's some number of megabytes, it's just a bunch of switches on and off.
My Xbox gonna be 250 gigabytes.
Yeah, 250 gigabytes would be 250 billion bytes. If you have
Oh my god.
a gigahertz as well, if you have a compute, that measures how many instructions per second can be done. So a